Good evening, all. Welcome to the second day of Electric Vehicle Certification Program. Before getting into the session, I am reminding you that this is a 4-day certification program. The certificate will be available only after the 4th day of the session. The certificate will only available for those students who have complete attendance in this session. Otherwise, they won't receive the certificate. That means if any of you missed any of the session, will not receive the certificate. The certificate will be only available after the 4th day of the session. That means the last day. So for downloading the certificate, first you have to log into Amrita CRP. Under there's a registered event. There's a tab called certificate. From there, the certificate will be live only after the 4th day. So you can download your certificate from there. If you have any queries, you can just type it in our chat box and we will discuss it with you. So we also have a Telegram channel. Join our Telegram channel to get more updates relating to BTech admissions and other event related details. And we will send you a notification regarding the BTech admission and other event details. Along with that, we are also conducting the mock test on every Sunday for you guys. So you can join the mock test by registering your name and you can crack your AEEE and JEE exam through that mock test. So we'll start the session soon. We'll start our session soon.
Thank you, Parvati. I hope you have understood regarding the certificate and things. So yesterday we had a discussion regarding the power generation with renewable energy, and we have discussed what are the advantages of the same also. I hope my screen, audio, video and everything is clear. So if you have any difficulties in the same means, you can just put it in the chat box. We'll clear you the same. And if you have any queries also, you can just add in the chat box. So yesterday we had a discussion regarding the same, and I hope you have understood how power is generated with the help of renewable energy and controllers and the things we had a discussion yesterday. And now let's see let's move on to the little bit higher level. Maybe you have heard this topic smart grid technology, or else if new to the smart grid also, it's fine. It's simple topic only. Don't worry that it is a new topic so that you will get confused. It is not like that. It is very simple topic. So let's see what is smart grid and how it is designed and how it is used with different systems. So before starting the same, I would like to know if you have any idea about, or else if you heard at least smart grid, you can just raise your hands. You can just raise your hands if you heard at least the topic, or else at least the word smart grid. You can raise your hands. Okay, it's really good. I have seen so many participants have raised their hands. It's really good to see that. So I hope at least few of them have idea regarding the same. So before starting to smart grid, yesterday we had a discussion regarding the power generation, how it is done and different types of power generation. We had a discussion. So today let's see how this is reaching the customer, or how it is reaching the destination, or how it is reaching the users, how it is transferred to the user. So in our systems, in our area or region, the things are happened, the transmission is done with the scheme which, or with the block diagram I have shown in the screen. So in that you can see initially we have a generating station over there. So yesterday we have seen how it is how power is generated, right? Even if it's a solar or hydro or wind, these are the three major power generating sources. So based on that, power is generated in the generating station. I hope you can see in the left hand side, even you can see the cursor, I have kept it in the left hand side, you can see there. Okay, so after that we have to step up the voltage or current according to our requirement for the transmission. So the equipment or the machine which is used to transform power, which is known by transformer. I hope you all learned, I mean, like transformer in your physics. So transformer, it's a device like which is used to step up or step down the voltage uh, to our requirements, or our, I mean, like record whatever we are required. We'll use transformer to step up or step down the same. But here we want to step up the, I mean, like power for transmitting to the destinations. Why we are stepping up the voltage? Since like it have to, I mean, like travel long, or else like we have to reduce the loss, and so many things are concerned. So regarding that factor, concerning that factors, we are stepping up the voltage and we are transmitting. So maybe you have like in roadside, or else like in paddy field, you have seen these type of transmission line. I hope you have seen these type of transmission lines. This truss work, or this truss, like you can see two tower over there. That is the major transmission line, and same it is like connected to the substation, or else like maybe your home locality or nearby your home, or else some region, I mean like the entire region, it's divided, and each and every region will have a substation. Why we have substations? Since we have stepped up the power, or stepped up the voltage after generation, and we have to step down the voltage, right? So the stepping down of the voltage, it's done in the substations, or substations maybe like near to your home, you can also see, and you can just go there and you can see what other things happened. So any of you have visited substations? You can just raise your hands if you have visited substations. It's really nice. I have seen few of them are visited substations. If you got a chance, please visit substations. And if you want to work upon electrical items, or work upon electrical engineering, or you just want to do research in electrical engineering or electrical vehicle or whatever it may be, initially you have to visit substations to understand what is happening there. So same way, like you will understand what are the things happening there, and what are the materials, and how it is done, and stepping up it's done, how transformer works, and different type of transformer you can see, and the things you can study from there. Even like you will get more practical exposure if you visit substations. So again, from the substation, the other thing is, the next is like customers, right? Customers means ourselves, like your home, or else some residential building, flat, villas, or industry, maybe industry also. So you can see that like we have a customers over there in the right hand side. So finally power will be, or the supply power will be reaching the customer end. So we are utilizing that for our different home purposes, or to run different appliances, like from the kitchen to mobile, even charging mobile, everything is done with the help of this power, or I mean like supply, right? So this is how like general, I mean like a power transmission and distribution, it's done. So with the help of transmission and distribution, like these things is achieved, and we are maintaining the same. So what will happen if we don't have required power? It's generated in the generating station. So it is a question to you. You can just put it in the chat box. What will happen if the power generated in the generating station does not satisfy the customers, or else like the customer demand it's more, customer need more powers, but the power generated it's less? What will happen? You can just put it in the chat box. What will happen to the system? So obviously power shutdowns will happen. I hope like in so many cities, even nowadays, like we'll have, even nowadays, like at least like it will be reduced, but in later a few years back, you will have shutdowns even in Tamil Nadu region. I have seen, I mean, like so many regions also, even in Kerala, we had like so many regions, like we had shutdowns, right? Why these shutdowns are happening? To maintain the demand, and to maintain the, I mean like a power supply to reach every customers, like since the generating power, it's not meeting the demand, so we'll having the power shutdowns, and things are happening, right? So how we can rectify this? Any suggestions from your side? since like we have a system of generation and transmission, but we are failing so many issues, like a power shutdown is there and so many losses and so many things are happening, right? So how we can rectify this power loss, and moreover that like this power generation problems? Any idea, any suggestions you have, you can just add in the chat box. Anyone? I didn't see anyone. It's typing in the chat box or something. So to solution for these problems, the problem number one is like generation of the power, it's not demanding the customer's demand. And the problem number two, it's like losses, fault, even if it's like we have bigger rain and the things which happening, and it will cause fault and will power shutdown will happen and things are happening, right? You can see that is happening in India, right? So these type of issues are happening. To rectify these problems, the grid system have been introduced, and so that's why we have moved to the grid system. So grid system, it's like a smart grid system, the general grid system which we are using in our hometown or in our area. It's this figure which I have shown in the right hand side. You can see that, I mean, like you can see that what's happening there. And see, you can see generating station is there and transmission system is there, and again here two generating station is connected to the transmission system. And from that transmission system, it is going to the distribution system. Distribution system means you will see the roadside some post, I mean like, or the post with some leg, right? You can see these type of posts, so that is like distribution system. From there it is giving to the load. I have mentioned it as load, means like the ultimate customer, or else like the using it is load, right? So if it's residential villa, or else like if it's a flat or whatever it may be, it is the load, right? So generating stations are connected to this transmission system, and transmission systems again from there it is connected to the, and power it's traveling to the distribution system, and from there it is traveling to the load. So this is how general grid system works. So telling about these things, I just want to ask you, what is a grid? What is a grid? So you can just put it in the chat box. What is a meaning of grid? What is a meaning of grid? Okay, I have someone have typed something like to measure the power, or to someone have typed. So grid is nothing. It's a channel which will transfer the power from one end to the other end, right? We need a power transfer, I mean like channel, right? Or conductor is required to transfer the power which is generated in the generating station to the destination, right? So grid, which is used to transform the power from the generating station to the destination or the load or the customer. So this is how like grid system, general grid system works in our area, or else in India, maybe like it's working. But later on what happened means we had a lot of losses in this system, and the power generation, it's not up to the level, and we had so many power shutdown issues, and we have like a lot of issues like we have faced. So to rectify these things, human have found out a smart system. Maybe your teacher will tell you you are a smart boy or you are a smart girl, right? Why they will tell you you are a smart boy or smart girl? Since you will perform more, or else you will be more energetic, or you will be more active, or else like you are different from others, right? So same way the grid system, it is transferred to a smart grid system. So let's see what is different between, what is the main difference between this normal grid system and a smart grid system. So we had a grid system which I have explained already. So next we'll see what is a smart grid system. Smart grid system, it's nothing, the system which can communicate, or a system which can find out the fault, and it can able to detect the fault and rectify the fault without any human, like human don't need to interfere in that. Like if suppose like in the normal grid system, what will happen if it's a big rainy season, it's there, and a big tree fall in the transmission line, the power shutdown happened, right? So what will happen? These things to be avoided, right? So we have an underground, I mean like idea, or else like things is there, right? Since if it's not underground means, if it's a smart grid system means, at least the human will get notification the system have gone fault and it have some issues in the perspective, I mean the respective area. So when the human or the person receive the information, we can go easily and rectify the same. So what will happen if it's not received means it will be power shutdown till morning, and we can't even like we can't think right that what's happening. And even like you have slept without power even one day. Nowadays it's not happening, but in maybe in few years back, like even we are in childhood, like we had a situations like that. So these things are happen. So to rectify these problem and to maintain an efficiency, 100%, not 100%, somewhat like 80 to 90% efficiency in the transmission, it is achieved with the smart grid system. And generating problems, I mean like the power generation issues, like in the normal grid system we have only a one generating stations over there, right? We have only a one unit. Like if it's hydro means hydro will be there, and if it's like a solar means solar will be there. Mostly hydro it's used. So to considering these issues, smart grid system it's introduced by a human being. See, people like you only studied these and they have found this and they have developed this, and these systems have been used by human, right? So if you are interested means you can also find some good systems. You can also do some research over here, and you can also find some good technique to improve the quality of power transfer. So same way the smart grid I have found, and it is a system, or that is a electrical supply network that uses digital communication technology to detect and react to local changes in the usage. Local changes in the usage means if assume a factory it's running. A factory means like morning to evening it will run, night it will shut down, right? So more power demand in from morning 10 a.m. to evening 5 p.m., right? So this have to be achieved by the generation, or the power have to be generated more in the morning time, right? But even during night time, what will happen? The residential people will use this power more, but the factory people will use less power, right? So this balance of this demand of power usage and these things have to be managed. So these things can be managed easily with the help of smart grid system. So let's see what is a smart grid system. Assume we are in a small town. You can see a figure over here, and you can see a small building over there, and we have a residential villa over there, and even you can see this windmill which we have discussed yesterday. One, two, three windmill. I hope you have seen, right? Windmill. You can just raise your hands if you've seen the windmill in the figure. Just raise your hands. Yeah, it's perfect. So again, a small car is there. I hope you can see the car. A small car is there, which is like charging from a EV station, right? And again, you have a solar panel over there, which is used for generating the electricity. So you have seen a small city, and you have seen some residential building, and with some villas and some power generating stations, power generating units. See, we are going to connect this entire system to a, assume this is a controller. So we are going to, you have seen one plug image, right? So we are going to connect entire system to a plug. So what will happen if we connect the entire system to a plug? So entire systems can, we can able to see what's happening with the entire system, right? So on the right hand side, you can see a windmill, you can see a solar energy and nuclear and thermal power station. So these are the major generating power stations, which is again connected to the grid or smart grid, right? So, and moreover that on the top of the building, you can see some signals. Even in the villa, even in the building, you can see some signals, right? Signals means what? Why that signal is required? What is a signal? Which is like, what is the need of signal here? Which here we are transmitting the power. What? It is the signal which will indicate how much power is required or demand for their, I mean, like building or for their load. So what will happen if we have a good communication system between these generating station and required customer and or the load station means we can have a smoother operation of power, and there won't be any power loss or there won't be any power shutdown which will happen, and the entire demand and generation will be balanced. So we can have a smoother operation of power, or like we can have a easier operation, and we don't need to face any fault also with this. And if any fault occurs means the system will automatically give information to the smart grid system, and it will automatically fetch and resolve the same. And if it's human interference is required, human will come there and rectify the same. So this is how human have beautifully designed the smart grid system, and we are using the same. And I hope like smart cities have been developed. The things will be developing. I mean, like the researches are happening soon. Like we all will be connected to this type of grid system, and even like the things are happening, and we'll be having a smoother operation. So this is how like smart grid system, it's designed and it's working. So beyond that, I just want to tell you how it becomes smart. See, if your teacher is telling you are a smart, so obviously you will have some qualities, right? Some qualities more than your friends or the colleagues, right? So the same, let's see what are the qualities of this smart grid system. The first one is like it have some sensors to sense the values, and it have some good communication systems. And moreover, that renewable energy and electrical storage system, it's available with the smart grid system, and will have a distributed power generation. And we can have power generations from solar, wind, hydro, nuclear. We can connect entire system to the grid system, and we can have a smoother operation. And demand response will be there. And demand means like we will fetch the information from the I mean like customer, whether like how much demand or how much I mean like load it's required, how much power it's required. Proper communications will happen, and we'll have a smart meter and building automation. Smart meter means automatically it will I mean like inform the things and automatically fetch the things and automatically work based on the I mean like requirement of the customer. It will work, and we can see the entire operation, what's happening in the meter and what's happening in the system, and things can be easily done. And building automation means I mean like nowadays like already few buildings or things have been automated. Automatic lighting system, automatic like cooling system, everything have been already came. So it will be working automatically. We don't need to worry about any operation in the building. So these are the features, or else these are the quality or the special features of the grid system, or maybe we can say these are the components of the grid system, which is like interconnected, and it is like working on the same. So next, and more view, I mean like a more practical view, maybe like I hope like you have understood that, but still if you've seen this you will understand more. So smart grid is nothing, it is like connected to the entire generating stations, and you will have a controller over there in the left hand side corner. You can see a control center, right? The control center will control the entire operation, or it will monitor the operation whether the things are happening in a smoother way. So we'll have a building, photovoltaic, I mean solar system is there, hydropower is there, thermal power is there, wind turbine is there, and smart homes is there. Smart home is nothing, everything is automatic, like automatic door, light. I mean it's like we don't need to I mean like switch on and off. It is like automatically fetch, I mean like sense whether human is there, it will automatically work everything, and things are happening. So these things are connected to the smart grid, and ultimately now electrical vehicle is also going to connect with this smart grid system. How it is like electrical vehicle is using smart grid, we'll see in the I mean like next session, and hopefully you have understood what is a grid system and how this is like have been designed and how it is like working, right? So let's see a video so that like you can understand more what is a grid system and how it's working. Okay, just give me a minute, I will show you a video so that like you can able to understand what's happening with the grid system.
Our current electric grid was conceived more than...
I hope you can see the video, and if you have any audio issues, please tell me. Okay, just understand how the smart grid is working.
100 years ago, when electricity needs were simple. power generation was localized and built around communities. Most homes all energy demands, such as a few light bulbs and a radio. The grid was designed for utilities to deliver electricity to consumers' homes and then bill them once a month. This limited one-way interaction makes it difficult for the grid to respond to the ever-changing and rising energy demands of the 21st century. The smart grid introduces a two-way dialogue where electricity and information can be exchanged between the utility and its customers. It's a developing network of communications, controls, computers, automation, and new technologies and tools working together to make the grid more efficient, more reliable, more secure, and greener. The smart grid enables newer technologies to be integrated, such as wind and solar energy production and plug-in electric vehicle charging. With our participation as informed consumers, the smart grid will replace the aging infrastructure of today's grid, and utilities can better communicate with us to help manage our electricity needs. The smart home communicates with the grid and enables consumers to manage their electricity usage. By measuring a home's electricity consumption more frequently through a smart meter, utilities can provide their customer with much better information to manage their electricity bills. Inside the smart home, a home area network, or HAN, connects smart appliances, thermostats, and other electric devices to an energy management system. Smart appliances and devices will adjust their run schedule to reduce electricity demand on the grid at critical times and lower consumers' energy bills. These smart devices can be controlled and scheduled over the web or even a TV. Renewable resources, such as wind and solar, are a sustainable and growing source for electric power. However, renewable power sources are variable by nature and add complexity to normal grid operations. The smart grid provides the data and automation needed to enable solar panels and wind farms to put energy onto the grid and optimize its use. To keep up with constantly changing energy demands, utilities must turn power plants on and off depending on the amount of power needed at certain times of the day. The cost to deliver power depends on the time of day it is used. Electricity is more costly to deliver at peak times because additional, often less efficient power plants must be run to meet the higher demand. The smart grid will enable utilities to manage and moderate electricity usage with the cooperation of their customers, especially during peak demand times. As a result, utilities will be able to reduce their operating costs. By deferring electricity usage away from peak hours and having appliances and devices run at other times, electricity production is more evenly distributed throughout the day. The power being used right now was generated less than a second ago many miles away. At each instance, the amount of electricity generated must equal the consumption across the entire grid. Smart grid technologies provide detailed information that enables grid operators to see and manage electricity consumption in real time. This greater insight and control reduces outages and lowers the need for peak power. In control rooms across the grid, engineers will be able to more precisely and predictably manage electricity production, reducing the need to fire up costly secondary power plants. The distribution system routes power from the utility to residential and commercial customers through power lines, switches, and transformers. Utilities typically rely on complex power distribution schemes and manual switching to keep power flowing to their customers. Any break in this system caused by storms, bad weather, or sudden changes in electricity demand can lead to outages. The smart grid's distribution intelligence counters these energy fluctuations and outages by automatically identifying problems, then rerouting and restoring power delivery. Utilities can further use distribution intelligence to predict and manage electricity usage with the cooperation of their customers, leading to lower production cost. The charging of a plug-in electric vehicle can be managed over a home area network, or HAN. The HAN can balance the demand for electricity across the household and prioritize between the electric vehicle and other appliances to manage electricity usage and reduce costs. With smart grid technologies and consumer participation, utilities can more easily handle the increased demand for power to run the electric vehicles and ensure charging needs are met. By adding more plug-in electric vehicles to the grid, we have the potential to reduce fuel costs, lower our dependency on foreign oil, and help reduce greenhouse gas emissions.
So I hope like you have understood what is happening with the grid system. I mean, smart grid system. So I hope you can, I hope like you can see the screen, right? Yeah. Yeah. So now let's discuss a few more things about the smart grid technology and things. So now you have got an idea how it's like a smart grid it's working and how things are happening, right? So now let's move on to further more information, or like let's see further few more information regarding the same. So you have seen that like communications it's happening, and in the screen you can see, just give me a moment, I will enlarge the screen. So we have seen smart grid and smart grid components, and now let's see few more information regarding the smart grid. So like as we seen the video, as we seen in the video, like we have a data network, an electrical grid network, and a smart measuring system, right? So these are the three unit which is working, or else the main components of the smart grid, so which is working behind the smart grid system. So the first and the major network is data network, right? Without data, nothing is possible in this 21st century. So data or the information, it's a major concern or the major thing. So these data have to be handled and it have to be analyzed to predict or to see what's happening with the system. So same way, data means it will fetch whether any fault is there automatically. It will inform the human, or else it will inform the person who is handling the same, or else if it can automatically, I mean, like correct the same means the smart grid system will correct the same and reroute the things in a smoother way. So again, this is a, I mean, like a block diagram or an explanation of the smart grid system, which you can see blue lines are the data network line and red line is the electrical grid network, and you can see smart meter system in the almost in the all loads means like building, electrical car, you can see electrical car in the right hand side, and you can see smart homes, and you can see, I mean, like the next centralized like a mall, and you can see some generating station also. In the topmost, you can see the generating stations like windmill is their energy storage unit. It's also there. It's a backup. They have kept storage unit also, and control center. You can see in the sender a control unit is there. It will control the or monitor and control the entire operation of the in smart grid system. So this is how like human have designed the system, and like we are using the same, so we'll have a better, I mean, like things, and we'll have a smoother operation with these power supply and the things is happening. So let's move on So let's move on to our area. So for example, like if we are using the same, even like anyone of you have used this on-grid solar system or off-grid system in your home, you can just raise your hands. If you are using solar grid system in your home, you can just raise your hands. I mean, like raise your hands. That's really good to see that. Like I can see around 5 to 10 participants have raised their hands and they are using, I mean, like solar grid system in their home. It's really good actually. And now in that system also we have like off-grid system and on-grid system. Off-grid system, it's nothing means it is not connected to the grid. We have a solar panel, and you can see in the left hand side you can have a solar panel and you will have a charge controller and you will have a battery. What is the use of inverter? We have discussed yesterday, right? What will happen? What power is generated in the solar system? It's DC, right? So to convert DC to AC, we have an inverter system, an inverter again which will convert DC to AC and it will connect it to the home appliances. So AC will be AC power supply will be given to the home appliances, and we are not connecting to the grid system also. So next thing is like we have an on-grid system. So yesterday I had a query that like battery will also pollute the environment, right? Obviously it will pollute, but imagine like what will happen if battery it's polluting, it's in a shorter way, but like what will happen if it's if one continuously a vehicle is running in the road means what will happen? It is like polluting almost like when it is started running and it will start until the destination it is like running, right? So it is polluting the environmental how many more times more rather than this type of battery pollutions, right? So obviously it will pollution is there since like researches are going on to recycle and things to be more, I mean like make it more, I mean like lesser pollution or to make this pollution to be reduced. The researches are going on and people are finding good ideas also. So even like I have seen yesterday, I have seen one article that like even 20 million batteries will be dumped, I mean, at the end of 2030 from this car or any equipment. So this is going to happen. So based for that, like again, recycling things are happening. So people are, I mean, like finding people, researchers, things are happening in the how to recycle and things to be smoother and without affecting the environment or to reduce the pollutions. So considering that, I mean, like the battery is better. Even like 20, I mean, like the vehicle it's running full time, it's like releasing the like pollution which it's stuff, right? So yesterday I had a query, so I remember that, that's why I have cleared that. So let's move on to our topic. So we have off-grid system and on-grid system. So off-grid system, which I have already told, we have a battery backup and inverter will be there. And in the on-grid system, see, we don't need any battery backup. Why? Since like we are connecting to the grid, if solar it's not working means what will happen? Automatically grid will fetch, I mean, like the power will be fetching from the grid and which is connected to the smart meter, and smart meter will fetch the information and automatically adjust and supply to the load or the residential which is kept over there. So this is how like on-grid system and off-grid system works. And this is a small example so that like you can able to understand what is the difference between this off-grid and on-grid system. So this is how like, so which one you feel more comfortable? First one or second one? You can just put it in the chat box. Which one you feel it's more good? First one or second one? You can just add in the chat box. Like you can just add in the chat box like you are feeling which one is good actually. First one or second one? Yeah. First one. Again, I'm seeing few of them are telling first one. May I know what is the reason? You can just put it in the chat box. What is the reason you are telling first one? Since we have discussed the smart grid technique also, you are telling first one is better. Why? For residential purpose, it's fine actually, but I'm telling in general purpose, like if it's considering on-grid solar system means we don't want to worry about this battery systems or inverter systems. I mean, like we don't want to, I mean, like worry about this battery backup or something, or charge control is also not required. We have a grid system over there and automatically grid system will fetch the power and it will adjust based on the system. So obviously the second system, that's good system. So hope in future also everything will be connected to grid. So we'll have a smoother and easier operation with the grid systems. So next we'll see how this communications has happened. So people have found out for initially the electrical grid system, and afterwards people have found, I mean, like they have done research and they have found out smart grid systems. And again, the people are doing research and they are finding more technology, or else new technology. I hope you have like idea about AI, artificial intelligence, IoT, and cybersecurity. These are the recent technology, and even EV also, such also upcoming recent new technique. So IoT, it's going to add with this smart grid system. So basically, what is IoT? So IoT, it's nothing. I hope you are using internet at least some time in your day, right? Even like we are having this presentation through internet, right? So how communication is transferred? It is through internet, right? So we are having video conference and like we are having these type of presentation through the internet, right? So same way the data it's exchanged or the things like exchanged and it is happened, right? Same way internet of things, like if we have a system, the system will obviously have some sensors. Assume the grid will also have a smart meter, and smart meter will measure the power required value. So this value have to be transmitted to the controller, right? So how it is transferred? It is transferred through the internet or internet facility, like it is transferring to the somewhat like some assume the system which is operating in Coimbatore or Cochin, and the center it's located in Bombay or Delhi. So we have to transform the data immediately, right? So how it is happened? It is because of the IoT facility. IoT will transfer the data, fetch the data without any delay to the controller unit. So that like control unit will put the same in the action, and it will take action, and it will do the needful what is the data they have fetched, and it will automatically adjust the thing and automatically change the things, and automatically you make this operation in a smoother way. So this is how IoT plays a great role with this grid system. And that's why like IoT have been used, and you have seen signals over there, no? So IoT will be fetching the data and it is transferring to the operation, and the service, if any service is required, service provider will reach the destination and it will clear the things and will have a smoother operation. So communication flow, it's like shown in the figure with blue dots or blue lines, and the electrical flow is shown with red lines. So communication have to be happen more, right? Since data transfer it's important, and data it's an important value, important thing in whatever system. If we consider data analysis, data prediction, and data collection, it's an important thing. So without data we can't even imagine the process, right? So data is a major things. From that data only we can predict what's happening in the system, right? So data it's fetched and the information is shared and things are cleared with the service provider, and we'll have a smoother operation of the grid. So this is how IoT have been fetched with the system. And you can see the basic comparison between traditional grid and smart grid. In the metering system, it's also we have an electromechanical solid state meter, and we'll have a digital meter or microprocessor meter. And communication means it's one way, right? In traditional system, we have only a one-way system, and the other one will have an integrated two-way or global communication system. And if it's customer interaction means it is like limited, right? Traditional, we have only limited customer interaction. And if we consider smart grid means we'll have a extensive, or else like 24 into 7, like it will be working and we don't want to worry, right? So things are happening. And generation, it's centralized, but it is not distributed in the normal one. So it is like in another case, smart grid case, it is like centralized and distributed generation. And power flow, it is like limited protection, monitoring and control system. And third, it will have adaptive protection and will have a smoother operation over there. And it's blind, right? In the normal system or traditional system, it won't monitor what's happening, right? If anything happen means we have to call the like electricity people, and we have to inform, and things have to be informed, right? So other system self monitoring will be there in the smart grid system, and things are happening. And restoration manual, and it is automatic self-healing things are happened. And if it's operation case also, equipment is done monitored in the smart grid system, and control will have a limited control system only in the first one, and will have a smoother and easier control system with the smart grid system. And if it's a reliability case also, smart grid is better. And topology means like it will have only radial, somewhat like radial topology. The other one, it's like the networking. Networking means like a communication we can exchange, and things will be more networking. So this is how the major differences between the traditional grid system and smart grid system. So next, let's see what are the benefits of grid connected solar system, which we have already seen. It's affordable, and like we don't want to worry. It's more reliable and easy installation, and it's like mostly 100% renewable energy. It's used with these type of grid connected solar systems. Right, so these are the major benefits of grid connected solar system. And next we'll see what is the major advantages of grid system advantages, like the entire smart grid system advantages, not grid, it is smart grid system advantages. Okay, don't mistake. So these are the major advantages, like if it's like communication will be there, an increase of diversity factor, reduce plant reverse capacity, and increase reliability of supply and exchange of peak load. If suppose like one generating station it's not working, I mean, like if it have some issues, the other generating station will manage the same, and will can have a distributed and interconnected system, generated system, so that like we don't have any issues also. And we can connect any generating station also. If it's old or new, we can connect the entire system, and economical, since like we can reduce the cost of bill also, since we kept in smart metering system and things which we have like in the smart grid system. So this is how like grid system will improve. And let's see what is happening in the today's energy technology. So today's energy technology, it's basically deal with the things like what is happening here means like with the new technology, which I have already told, IoT, AI, and data analytic process, which is used with these systems, and things are developed and which is incorporated with the smart grid systems. For example, AI and cloud and digital technologies allows the device and asset within the grid to communicate, and some better control and self-regulation, which is happening because of this AI and cloud and digital technology. And even this IoT, it's used to fetch the sensed value and to find like whether any load issue is there or some fault is there. It will automatically fetch the things, and it will automatically correct the things. So this is how IoT, it's also playing a vital role with the smart grid system. And even predictive analytics, you see, if the data is collected, right, so based on this data collection, data will be analyzed, and they will predict based on the analysis. And if something is going to happen before, it will automatically predict that, and we can avoid that type of issues also. So predictive analytic process will be there, so it will smoother the operation, so we don't want to worry about any issues in the grid system. And self repair and predictive maintenance will be there. And customer choice, like we have like different types of things will be there, so we can choose based on our requirement, like our load demand, like we can choose whatever load we require and whatever things we require. So I will show you a short video so that like you can able to understand like what are the new technologies which is incorporated with this grid system. So with that, like we can wind up. Just a second, I will play you the video.
The world of energy is changing, and change is good. It creates new opportunities. As long as we can adapt, the potential is endless. But in the world of energy, change can be difficult. It's fast and complex, and we still need to maintain grid stability and power quality, ensure cybersecurity, and provide affordable and reliable energy. Rise to the challenge. It's time to accelerate the change by driving energy intelligence. From the smartest way to control your grid, to the new opportunities at the grid edge, and across connected electrification solutions. Imagine the possibilities once the grids are truly smart. it will be possible to operate and maintain grids with confidence. Use data to create transparency and react quickly to whatever's next. Ensure an energy supply that meets every requirement. We at Siemens are driving energy intelligence so you can master all the changes today and tomorrow.
Siemens, ingenuity for life.
So this is how like new technology have been incorporated with the smart grid system, and things are developing, and even people are doing research to have a better smart grid system and it's like a smoother operation of this entire system. So I hope like you have understood about like smart grid system and what is the new technology which is incorporated with the smart grid system. And thank you, and we'll see you tomorrow, and thank you. And if you have any queries, means you can just add in the chat box, like we'll clear you the same also. Wireless power supply, I have seen one queries regarding wireless power supply. Wireless power supply is possible, but still researches are going on, and hopefully it will have some issues also. It will be rectified and people are doing researches on the same. So thank you students, see you tomorrow and happy evening.